All right, so in this section, we're going to do 6-4 notes, point slope form, and writing linear equations. We're going to focus on two things in these notes and kind of see a bunch of different forms of it. But one is we're going to focus on how to write the function rule for in point slope form. And then we're going to focus on graphing it. So those are two things that we're going to focus on doing today with this. Write that down. All right, so those are two things. So point slope form is a third form. This is the last form that you'll learn for linears. We've already learned slope intercept form, which should be our favorite, should be the most common one that we use. Y equals mx plus b. Where we've got slope for the m, and we got b as our y-intercept. And then we learned yesterday, we learned standard form, which is ax plus by equals c. And we learned the standard form is really good for graphing the intercepts, x and y intercepts. We could quickly find those by putting in 0 for either the x or the y to find the corresponding intercept. Point slope form, on the other hand, is really good for writing an equation. Let's highlight that because that's fairly important with this. Writing a function rule. Given a little bit of information, all we really need, like it says, is a point and a slope. So if we have those two things, we can quickly write an equation. We never really talked about it, but to write into standard form is pretty complex. It's something that we won't do a lot of time with. And then with the slope intercept form, it is something we can do. We do need slope and we need y-intercept here. And sometimes if we don't have our y-intercept, that's something that we have to calculate, which can make it, it's useful because we can do it, but at the same time, it's a lot easier to write right into the point slope form. It's made to be able to calculate it, or no, without any calculations, we go ahead and write the equation. So by definition from the book, the point slope form of the equation of a line is a non-vertical line that passes through the point x1, y1. So really you just need any point is what that's saying there. Let me highlight that. I'm trying out all the colors here to see which one my favorite is. So any point is really all that we need. And the other piece of information that we do need is our slope here. So if we have those two things, we can write it in the general form. I'll highlight it down here at the bottom. Y minus y1 equals slope times x minus x1. And we will probably want to note here that there is two y values and two x values, and there's some negatives here. And so let's point these out before we move on so that we really kind of understand the form, because we don't want to get stuck guessing at where the negatives are. This form comes with a negative as it starts. So these two values, x and x1 and y1 over here, have a subtraction sign, a negative between them. That's how the formula starts. So if we insert a value for y1, it may change that negative to a positive if the y value is a negative going in. So we have to keep track of that. When we put in a negative value, it's actually going to turn the sign to positive. And the same thing for the x1 value. If we put in an x1 value that's negative, it's going to change the sign to a positive. So we need to keep track, or at least need to remember, that it starts with a negative value. So let's write that down. Starts with a negative value. There's my with sign. All right, negative value. All right, so we got to keep track of that. That's one thing that you got to remember with this form, is that it is supposed to be negative when it begins, and if it's positive, that means a negative value went in there. You can see the slope there. Slope just sits out front here, and it looks kind of funny. This doesn't look like a big fancy form. We like to see y equals mx plus b, or ax plus by equals c, and this one's kind of spread out. It's got a lot of values, a lot of things going on. That's okay. That's the point of the form, to quickly be able to create an equation if you're given a little bit of information. All right, so let's move down here and start to use this form. First thing I'm going to show you is how to graph from it, although this will be something that we do limited. Rarely will you ever graph from this type of an equation, but it's kind of nice to understand how to do it if you were asked to. So graphing from this form is really just about understanding what it is and where the information can be found. You want to identify the point that's in the form, and you want to identify the slope. So we're going to do that first, and then we're going to graph that point, and we're going to graph it. Once we have this point, we're going to graph the slope after that, rise over run, which we're pretty good at. So we're going to find the point, graph the point, and then once we have that, we'll go ahead and calculate the slope. So let's go down here and see if we can identify some of this information. And again, I always like to start by rewriting the equation. I think it's a nice way to get used to the form of it. So in this case, it's y minus y1. y1 indicating the y coordinate of our point, equal to slope, we all know what that is, times x, the quantity of x, minus x1. And x1 is the x coordinate of our point. So the two pieces of information we're looking for is one, the point, y1 and x1. And we'll do that. And then after that, we're going to find the one additional piece of information that we need, which is m. Don't worry about x and y. They're just like the variables in standard form. They're just there. It's our input and our output. That's what's changing the situation. But we need to find these two pieces of information, y1, x1, and our slope. So let's look down at this problem and see if we can identify those. And I'll try to match them by colors because, again, playing with colors is kind of fun. So if we can see here, here's the location. Again, assuming that it is in full point slope form. In full point slope form, you should have a y value on the left with some number. Sometimes it can be gone. If it's 0, it won't show, so it'll just look like a y. So again, there's our slope, and on the right side, our slope is multiplied to some quantity of x in parentheses. So we can see it pretty clearly here. So we found our slope, so let's write that down. So let me find another spot. So slope then is 1/2. It's pretty much that simple. Nothing more to that. And then let's go ahead and find our point. In this case, let me highlight the same color so you can see it matching. Our point then is +5. Does everybody understand that? This is supposed to be a negative here. It's a negative in its true form, so that has to be a +5 that went in there. If it was a -5, this would be a positive there. Again, I can't stress that enough to keep track of that. This is the most common mistake done with this problem, is the mistakes with the sign. So if we're a little careful now, I think it'll pay off later. All right, so now we can write our point. Our point then is going to be, again, this is our y coordinate, which is the 5, +5, and then this is our x coordinate, which is the +2. So we're going to go ahead and write that down. So our point is 2, 5. And now we can graph like we've done any other time before. So we're going to graph our point. It's not the y-intercept, but that's fine. We don't have to have the y-intercept. So we're going to go down here and we're going to mark off 2, 5. So there's 1, 2 over, and we're going to go up 5. 1, 2, ooh, that's not a good, oh, now we got lots of lines everywhere. So we can clear these out of here. Erase those real quick. So let's go back to where we were. So 1, 2, 3, 4, 5. So that's our point. Let me change the color on it so we can see it clearly. I'll change it to a black because I'm using a red right now. So there's our point. And now we can do rise over run. Again, rise over run being here. So our vertical change is 1. Our horizontal change is 2. They're both positive. So we're going to go up 1 over 2, make a point. Up 1 over 2, make a point. And again, continue this process just a little bit, enough to create ourselves a point. I don't know how well I'm going to be able to draw this line, so bear with me. This is going to be not too bad. It's a little wobbly. Looks like some of your homeworks. Not my best line, but it'll work. So there's the line. Again, all we're doing is identifying the pieces of information that we can see right into the function. Again, our point comes from these locations, assuming that it's in this form, this point slope form to start. You may have to make it into that form. We might have to manipulate it. We might have to move an x or a y to get it in this form, but it has to be directly exactly in this form. Y minus y1 equals slope times x minus x1. Okay, I'm not going to do another one of these because I said I would keep the notes shorter, and I'm already taking some time. So we're going to move on down, ignore that, and we're going to get down here. Now we're going to attempt to write the equation, assuming they give us some good information here. In this case, they've given us slope. That was one of the pieces of information we need. And they've given us a single point. That's the other piece of information that we need. So now we have everything we need to write the equation of a line. So we're going to go ahead and do that. I'm going to go down underneath here because you can see I've changed my title right here. So I'm going to write down here at the bottom. So number 2A is going to be right here. So there's 2A. I'm going to start by writing the general form. This is what I want to see in your homework. I want you to start every problem that's asked. If you have to write something out, I want you to write the general form just like I'm doing now. So we're going to write y minus y1 equals slope times x minus x1. Okay, so now let's just plug in the information. That's really all this is. It's just a recognition right now to plug in the right parts into the right spot. So slope being m, there's a -3. This is our x coordinate, which is -1. Our y coordinate is 7. and we just have to input them in the right spots. So let's start to write this out. So y minus my 7, it's going to be a negative 7 when I put it in, because it's supposed to be negative here. Again, remember it starts out as a negative. Put my slope in, that's a negative 3. I'm going to put my x in. And now I'm going to go to, notice that we've got one here that has a negative. So we should see this negative x value when it goes into the equation. Two negatives are going to make a positive. Let me highlight the negatives so I don't feel like writing them twice. So here's the one negative. Here's the other negative. When I put this x value up here at the top, when I put this x value into this equation, you're going to see that that's going to make it a positive. So let's finish off writing this. So we're going to go down here. The two negatives make a positive, and that should be a positive 1. All right. Hopefully that clears it up. Again, I'm not going to do another one just to keep the notes moving pretty quickly. You can always go back and rewatch this anytime you need. All right, so let's move down here. Moving right along. Now we're going to go ahead and try to write the equation in point slope form, given that we've got some other information that we have to draw. In this case, we can see that they've already given us the point, nice and handy of them. But we're going to be given a line, and we want to write the equation of this line nice and quick. Realistically, we're probably going to use point slope form because I'm sorry, I said that wrong. Point slope form is very handy a lot of times, but realistically, we're probably going to use slope intercept form. Here's why. Right here, that's your y-intercept. It's super easy to see, so we could quickly write an equation for this. Our slope isn't going to be too hard to calculate at the same time. So our b would be, again, I'm showing you the way that we'll probably do it, but we're going to practice point slope today. And let's go ahead and calculate that rise over run. So we're going to go up 1, 2, 3, and right 1. So my slope is up 3, right 1, which just means my slope is 3. I wrote that kind of funky. Let me move it over so it looks right. And it's in the positive fashion, so it should be a positive 3. So we could quickly write an equation without much work here of 3x minus 2. Now over here, we're going to practice our point slope form. Let me change back to red here. Again, y minus y1 equals slope times x minus x1. Again, we need two pieces of information, one of which we already have. So if I can find my little point, which I tend to lose occasionally, we have one of them when we calculate it over here. We'll just pretend we'll steal it and come back over here and use it. So our slope then is 3. Now, the point can be either one of these 2 points. So we can use -1, -5. We could use the y-intercept that we found. That will also work. Or we could use this point 2, 3. Let's use the positive point 2, 3 because we're practicing. So I'm going to come back over here and write down my information that I've gathered. So 2, 3, there's my point. There's my slope. Now all we have to do is plug it in like we just did a minute ago. So I'm going to write the equation, y minus my y-coordinate. So there's my y-coordinate, which is 3. It's a positive 3, so it's going to look negative in the equation. So positive 3, or in this case y minus 3. My slope then was 3. And I'm going to put in my quantity, so x minus my x-coordinate, which is 2. And that's my completed point slope form. Okay. It did ask us to do slope intercept form. We did that first because it was something you're familiar with. And then we went back and we graphed in point slope form right after. So we've done both of those, like I said. Now, you can see down here when we jump to the next example, we are going to do this one. It says write an equation for the line in example 3. So meaning steal its slope is really what that's saying. But do it through the point -1, 5. Now notice that if we went back up here to our slope intercept form, is everybody following me? Right here. I got a little too much red going on. Let me switch some colors here. So if we wanted to change this formula, this form here, because let's say we wrote this, y equals 3x minus 2. And that's based off of the y-intercept. If we wanted to write it to go through point -1, 5 and asked us to do it, it would actually be the same equation. However, we'd have to recalculate or refigure out what was going on. Again, not too big of a deal there. But with the point slope form, it's as easy as just switching your point out. So again, let's start with our base form. Y minus y1 equals slope times x minus x1. Oh, that's a terrible x. All right, it'll make do. And our slope is the same. They told us that. And our new point, which would be -1. I think that's supposed to be a -5. I'm going to go ahead and use -5 because looking at the example, I'm going to guess that this was typed out wrong at one point for me. So put a little negative right there. All right, and then we can plug it back in and we can quickly switch to a new equation. So y minus our y coordinate, let's go over here, which is -5. That should be a +5 now because the two negatives make a positive. Again, hopefully everybody's keeping track of that. And there's our 3x minus our -1 here. That's our x coordinate. So that's also going to make a positive. So they look like positives in the equation. However, we're very clear that those mean negative numbers. So keep this in mind. On the reverse, if you see a positive in here and you're looking to draw out your point, which we'll be doing very shortly, that those values then will be negative when they come out. All right. So what is true about the two equations we just wrote? They are both linear functions. They haven't changed anything, and both forms represent the same linear function. There's no difference. So let's draw a little star here, or a little line. This, and I'll use green to keep the same color. This equation, y plus 5 equals 3 times the quantity of x plus 1, is the same as this equation. Y minus 3 equals 3 times the quantity of x minus 2, and is the same of the equation that we started over here, y minus 3x minus 2. They are all the same. Let's do a quick little change so you can actually see that. I'm going to do a little addendum in my notes here. So again, I lose my cursor. There we go. Let's go ahead and multiply this point slope form out here, and we're going to see if we can make it look like it's in slope intercept form. Because remember, that's one of our goals. I told you that was one thing that we really want to focus on this year, is making sure that we're good at changing our forms. So we're going to make our own question over here. I'm going to rewrite this to start. So y plus 5 equals, it's really hard to write at the same speed that you talk. I don't know if you guys knew that, but if you ever did try it on a pad, it is not as easy as you think. All right, so we're in point slope form. To get it to be in slope intercept form, like we are over here, slope intercept, it's an S and an I. It's getting kind of messy. Notice that we have to solve for y. So here's y. We can see it right here. Plus 5 equals 3 times quantity of x plus 1. So really what we need to do is distribute this 3 to get it in the right form. So we're going to multiply 3 by the x, and we're going to multiply 3 by 1. And then we're going to untie this 5. We're going to subtract this 5 up. But we're going to do the distributive property because that's the reverse order of operations, and we really do need to get that x mixed out of there. So let's rewrite the left side because we're not really doing anything. So y plus 5 equals 3 times x, which is 3x, and 3 times 1, which is 3. All right, so we're doing pretty good so far. The next step then is to get rid of this 5, so we're going to do the inverse operation. They're going to turn into 0, and I need to make sure that I do that same inverse operation to the other side. So y is left on the left side, and 3x, nothing changed that. And we got -5 plus a 3, which gives us a -2. And what you should see, I don't know if you're as excited as I am. Yeah, probably can't tell by my voice because it's late and I keep losing my cursor, so hang with me for a second. There it is. The blue is really hard to see. Is that this slope intercept form is the exact same as this slope intercept form. So, and we could do the same thing over here for this one. We could take this point slope form, multiply it out, again, distribute. We only really did 2 steps, distribute, and we did the inverse of our value. So we changed forms there. So by distributing and then reverse order of operations. Okay, we did 2 steps. So pretty easy problem to solve. Again, changing forms, we're going to focus on that. So make sure you do that if it's in the homework, which it is. Make sure that you change the form. Otherwise, we will spend some time with that, definitely on the review day and when I get back to class. All right, one little addendum, one little piece of information that I think I will save for another day because I want to keep this video short, is how to see something's linear. We've already talked about that a bit, so I'm actually going to save that. If it's in the homework, you can take a peek in the book. It's relatively simple, but I don't want to keep this video any longer than 20 minutes, and I'm cresting on that right now with 30 seconds to go. So we'll save that for in class. If you need to take a look at it, go ahead and peek in your book. You have the online book. Here is a review of all the 3 forms that we've talked about. Slope intercept form, again, That's the first one we talked about. Should be our favorite. Slope and y-intercept is really easy to find. If it is easy to find, it's easy to write. Again, solve for y. That's the key thing there. If we jump over here to standard form then was where we could solve. We had both a and b. Remember, they had to be whole numbers. They had to be integers. They couldn't be fractions or decimals. We had to clear them out. And it solved for c, oddly enough. So if you needed to solve for c or solve for the constant is the way that we would say that. That would put you in standard form. If you solve for y, that would put you in the slope-intercept form. And then point-slope form is just good for writing equations. And you really just need a point and a slope, and you can write it right in. Again, most of the times what we'll do is we'll write into the point-slope form if we're given information and we don't have a clear y-intercept like we do here. If we don't have a clear b, we'll write it in point-slope form, and then we'll change it most often than not from point-slope form to slope-intercept form. That's going to be what we do most of the time. Okay, just give you an idea. All right, Crescent 21 minutes. I said I was going to be done. Notice I changed your homework here. 1 through 17 odds, 31 through 35 odds, and 36 through 38 all. And don't forget that practice worksheet C. And this worksheet, let me squeeze a little C in here. This worksheet is just having you practice writing equations. So you're going to be given 2 points. You can write it in using point-slope form, which I recommend, especially from this homework, or you can use slope-intercept form, because realistically, whatever one you prefer at the start of these notes is to be the one that you do most of the time. So either one of those 2 forms, you don't write in a standard form, so don't worry about that. All right, good luck with your homework, and I will see you